We're going to talk about mechanical ventilation today, and in order to understand what mechanical ventilation is all about, you must first understand the basic principle of how a mechanical ventilator works. Okay, so essentially, what a mechanical ventilator is like a bellow. Okay, it just you have something connected to the lung, a tube, and it's like a bellow. So you just pump in the air and push the air into the lungs. Okay, but if it's so simple, then anybody can produce a ventilator. So there must be certain things that determine how to make the ventilator do what it's supposed to do, and how you control the ventilator so that it's able to deliver the work that you want. So just the three main phase variables in the ventilator. So if you understand that, then you understand how the ventilator works. So ventilator first needs a trigger, okay? Something to start off the ventilation, okay? Now, what can, how do you think ventilator can be triggered off to start the bellows, okay? Anybody? Okay. Okay, so it regulates the start of the So how do you make, let's say you're building a machine from scratch, how do you make a machine start pumping? Okay, there are two ways you can go about it. One is you can make it automatic. That means every few seconds you say, okay, every 3 seconds you must start to pump. Okay, that's how you can start the machine to trigger off. Or two, you can say that if there's something that the patient does, okay, then it triggers off the valve, right? So there must always be something, okay, that triggers off the machine to start to pump. Okay. Now once the machine starts to pump, then there must be a way to regulate the amount you pump. You can't just continue to push in the air. Okay, you can't just push in as much as you can. So there must be a way to regulate how much of the air that's going in. And usually you use either pressure or volume to limit the, okay, so the limit, okay, so this is to regulate the you know, and sustain the inspiration. So you're pumping in or you're pushing in the air, okay, so you use a limit to sustain the inspiration. And once you're controlling it in such a way that, okay, a certain amount of volume or certain amount of pressure is being used, then you must have a time where you say, okay, we are ending the breath. Okay, the breath can't go on forever. Okay, so there must be a way to cycle off, okay, the breath. Okay, so this cycling or ending of the breath also requires a certain trigger. Okay, and usually in most of our conventional ventilators, we use time, okay, as a way to cycle off. So we say, okay, we pump the air for 0.5 seconds, and then you must cycle off. But then there are also other ways to cycle off. So sometimes, most of the time, we are most familiar with using time to cycle off. Okay, that's what we all use in our ventilator when we adjust our I time, inspire time. So it tells you inspire for so much, cycle off, then you go into expiration. Okay, but so time cycle. But then there are also other ways, and one of the other common ways is using flow to cycle off, which I'll explain earlier. Using flow to cycle off is a more complicated concept to understand, but that is essentially what pressure support ventilation uses, PSV. Okay, PSV uses flows to cycle off. So you'll notice that whenever you put on the pressure support ventilation, you don't have an I time. There's no I time to tell you, hey, when should the breath end? Okay, so the breath, so that's one of the differences. So essentially, I think for our general concept, these are the two methods of cycling off the breath. You either use time, okay, which is the commonest method that we use, or we use flows, which I will explain to you all later once we go and talk more about pressure response ventilation. Okay, so what would be the goals of ventilation? When you decide, okay, this baby needs to be ventilated.
When the FiO2 requirement increase,
Is that the only thing?
or if the baby is not breathing, or respiratory distress, or like
Yes, respiratory distress, yeah, or the baby is not breathing, apnea, yeah. So if we want to improve either the oxygenation, okay, because FiO2 is increasing and the baby needs, or we want to improve the ventilation. That means either CO2 is rising, the baby is not breathing, apnea, and we want the baby to ventilate. Okay, to improve oxygenation or ventilation. Okay, and this is probably the commonest reason why we would do ventilation, is try to improve. But then there are other causes, other reasons. One is possibly to reduce work of breathing. Okay, so when would the situation be when you want to reduce work of breathing? When, let's say, there's poor cardiac output, septic child. Okay, so any increased work of breathing is going to stress the system. So then you would electively intubate a child that is in severe sepsis, even though the child is doesn't have much of a lung problem. Okay, so severe cardiac problem. So to reduce work of breathing. Okay, and ultimately we want to make sure that the baby is comfortable. Okay, that ensure that the baby is comfortable. So in other words, we want the baby not to be panting or working hard. Okay, so these are the goals of ventilation, and I think most of you are familiar with that, so I'm not going to talk much. Okay, so let's talk about modes. I'm just going to talk briefly, and then after that I think it's easier for you to understand once we test out hands-on. That's why I'm having a talk today, because we finally have a patient that's on ventilator. Yeah. So essentially I would group them into a few big main groups. Okay, in the days of the old, where there's no such thing as patient-triggered ventilation, and the machine is just working independently of the patient, then we have the CMV. Yeah. Okay. So basically, it's just a controlled mechanical ventilation. There's no feedback from the baby. Okay, the machine just works independently on its own. You just set the machine, how many breaths, what sort of pressure or volume, and what's the rate, and then the machine will just pump regardless of whether there's a patient, no patient, or whatever. Okay, so that's kind of something that most of the time don't quite use anymore, but we still consider using it in patients that are very severely sedated or paralyzed. Okay, so where there's actually not much need for feedback and the baby is not breathing much, then we use this mode because it allows us to give a very steady breath, very definite breath, which is under our control. But most of the time these days, we use some sort of patient-triggered ventilation, and the commonest ones that we're using now is either assist control. Yeah, assist control is basically sort of similar to your SIPPV. If you all are familiar with the baby lock, baby lock calls it SIPPV. If you use other ventilators, they may call it assist control. But essentially, anybody knows what's assist control or SIPPV?
we don't use it.
Huh?
You don't use it. Yeah. We don't really try to.
Do you know? Are you from CCU? So you should know what's assist control, right?
Assist control.
Yeah. So what's assist control?
Assist control. Only with soft talk to the.
What's the difference between assist control and SIPPV?
Maybe this one, the assist, there is some breathing. It's like
Okay, so
this
assist
one is
control or
control.
SIPP means it's actually a mandatory breath. That means it's a fixed breath. Okay, it pumps in whatever you have set. Let's say you set tidal volumes of so much, or pressure of so much, eye time of so much, whatever. It will give a mechanical breath. Okay, and it will give a mechanical breath every single time you breathe. So in other words, the moment I take a breath, it will pump the fixed breath. Okay? Alright? So in other words, there's no rate. If you breathe 10 times, the machine will pump 10 fixed breaths. Okay? If you breathe 20 times, the machine will pump 20 times. The same breaths that you have set. Okay? You have to set the breath. Alright? So that's what assist control or SIP. SIPV is your baby lock. Assist control is most other adult or pediatric ventilators will call it assist control, isn't it? In ICU, yeah. So, but in baby lock they call it SIPV. But
what's the mean of SIPV?
Synchronized intermittent positive pressure ventilation or something like that. But actually it doesn't matter what because every company who builds a machine gives it its own name. You just have to know what it means. Yeah. So basically, what it means when you put a person on assist control or SIPV is that the breaths that you have fixed will be given every single time the baby breathes. But of course, you may also put a minimum number of times. That means you say at least there must be 15 breaths. So if the baby only breathes 10 times, then they may additionally give another 5 breaths intermittently without any triggers. Okay? But if the baby breathes 20 times or 30 times or 100 times, the machine will pump in 100 times per minute, if that is what the baby is breathing. Okay, so that's what assist control is. Now SIV is different. Now SIV is also giving you a fixed breath, okay, which you have determined using your settings, but it only pumps in the number of breaths that you have set. So you put SIV 20, it will only pump 20 times. It's not going to pump more, okay, unlike your assist control. Now, so what happens if you put a SIV of 20 and you are breathing 50 breaths? What happens? Okay, so what will happen is that you will be having 2 types of breath. One is a pump breath, right, which is set by you, and in between the baby will be just breathing on his own, unsupported. Okay, so the baby will be breathing, and then when it's time to pump, he'll pump, and then breathing. Something like what you're seeing over there on the ventilator there. Okay. Over there. Yeah. So you can see when you look at the graph, you can see the intermittent breaths that are by the SIV, and those are the tall peaks. Okay. And then you look at the small little bumps down there, and those are the baby's own breath that are unsupported. Okay. You can see, right? So these are the breaths that are being pumped, the SIV breath. Okay, and these small little bumps are the baby's own breath that are unsupported. Okay, so that's what happens when you put the baby on SIV. So now, if it's assist control, then every breath will be supported. Now, pressure support ventilation. What is it? It's almost similar to SIPPV, right? Except that Okay, so pressure support ventilation is almost like SIPPV, except that the support given to the breath is variable. Okay, so unlike SIPV or assist control, the support given to every single breath is fixed, and you fix it by telling them how much volume to pump, what pressure to use, what sort of idle time to use. Okay. Now, when you use pressure support, it's a slightly different support where the only thing you determine, okay, and we're going to go on to the ventilator afterwards to explain to you, is what sort of peak pressure you use, all right, and how fast to terminate the breath based on flows. It's not easy to understand, and I'll explain to you later, but basically it is a method of supporting the breath which is supposed to be more natural, more in tune with the baby, and it's supposed to follow the baby's breath, because baby's breath are never exactly normal. Sometimes they take bigger breath, sometimes they take smaller breath. So the support of the breath are supposed to follow the baby's breath. Okay, so we'll talk about that later. It's not easy to understand how it works, but yeah, we'll try. And then of course, lastly, high frequency ventilation is a totally different form of ventilation. That one itself is one lecture, but just to be complete, that we have different methods of ventilation. So HFOV basically, to put it in a nutshell, is putting CPAP at a very high pressure with a vibration. That's what high frequency is. Putting a baby on a very high CPAP, okay, with a very high oscillation in order to move the gases in and out, okay, so that CO2 can be removed through that method, okay. But essentially, that's all high frequency ventilation, and we will talk about that. Okay, everything understood? Simple. Okay. All right. So as we mentioned earlier, nowadays this sort of mechanical ventilation is what we are targeting for. Why do we want patient triggered? Because that's the only way we can synchronize the ventilation with the breathing. Now, if the baby is breathing out and then you are pumping in, it's asynchronized, then there's a lot of excessive work of breathing, high pressures, more likely to get volume trauma. Patient will be very uncomfortable. So we want to synchronize the breath. Okay, and the only way to synchronize the breath, if you think about it, for any ventilator is the machine must be able to detect the baby's breath the moment he takes a breath. That's one. Two, the machine must be able to send a signal to down to the processor to start the breath the moment it detects the breath, and pump into the breath while the baby is still taking the breath. Okay, no point sending a signal and then by the time the machine realizes and they pump a breath, the baby is already breathing out. So the time so it's very important. In order to sense the breath, it must be very sensitive. Okay, you must be able to sense it very, very early and be able to process it and trigger the breath while the baby is still taking the breath, so that it will be synchronized. If your sensing is slow or your signal is slow, then you're gonna make it worse. Then you'll be synchronized into your expiration every single time. Every time you take a breath, by the time you pump, you're expiring and the pump is going in. So it must be a very good sensitivity. Okay. So how do we sense the baby's breath?
Using sensor.
Using a sensor, right? And what kind of sensors do you know of?
Sensor.
What? A
Flow
flow
sensor.
sensor. I think the one that we are most familiar with is the flow sensor. Okay, so that's the one that is that you see the baby being on, and the flow sensor is probably the most sensitive sensor we have at the moment. Why is it sensitive? Because it's very, very close to the patient. And that's the reason why the flow sensor is put very close to the patient, so that it can detect the breath as soon as possible. The further away the sensor is from the baby, then the longer it takes